Welcome to solverfy.
Okay, so in this problem, we're asked to identify a particular noble gas based on the following information. We have the density at 2.71 grams per liter. We also have a pressure of 3 atmospheres and a temperature of 0 degrees Celsius. Now, I went ahead and added the 273 to 0, so we have 273 Kelvin since we're in the ideal or in the gas laws unit. The big picture idea in this particular problem is that we need to find the molar mass of this gas in grams per mole. And we can identify, with that number, we can identify the gas on the periodic table. We would go to column 8, which is the noble or inert gas column, and identify our gas that way. But we don't have moles in this scenario, but we can use the ideal gas law to find that. So the ideal gas law is in step 1, it's PV equals nRT, and R is our gas constant, and we'll use the 0.0821 for this particular setup. And for volume, we can use 1 liter, even though we're not given that explicitly. We can use 1 liter from the density. So we know for every 2.71 grams of this gas, I know I have a volume of 1 liter. So we'll go ahead and use that in our ideal gas law equation. And again, we're trying to find the number of moles, which is N in this particular problem. So I'm going to go ahead and switch screens, and we'll go ahead and calculate N for this particular noble gas. And then our next step would be finding molar mass, and then we'll identify our gas. So for PV equals nRT, I'm going to go ahead and substitute 3 for P, 1 for volume. On the other side, we have our unknown N. We also have R. And the final number would be the 273 degrees Kelvin. Now on the left-hand side, we have 3. On the right-hand side, the product of 0.0821 and 273 is 22.4133 times N. And to isolate N, we simply divide by both sides by 22.4133, and we'll get to 0.134. I went ahead and rounded it to the thousands. So in this particular case, we have 0.134 moles of gas. Then our next step would be to determine what is the molar mass of this particular gas. And that would be a quick ratio calculation. So we know we have 2.71. So we have 2.71 grams of this gas. And now we know we have the 0.134 moles. And that comes out to be just over 20 grams, 20.246 grams per mole. Okay, almost done. And then our last step would be to go to the periodic table and look at column 8. And it so happens that neon has a molar mass of approximately 20 grams per mole. So we're going to go with neon as our final answer for this problem.